Hi, so the goal of this video is to quickly show some of the tools I use to prepare my literature reviews when I have some subjects to review, which tools I use today, especially with AI. There's many LLM tools that can help us do that. So I like to make a video that shows them all so it's easier mainly for my students to get started when they're not familiar with these tools. So let's say I have some work to do about a new subject I'm still learning about, and I want to know what the state of the art is. And ideally, I want to do that quickly, especially at the beginning of a new kind of subjects, a new field you're working on. It takes some time to get started and to get the basis and a description of the state of the art, especially when there's a lot of data to ingest about the subject. So the way I do it today is that I'll first start with a search on Google or Google Scholar. We won't even use Scholar in this case, just a simple Google search that contains some of the keywords. So you first have to identify the keywords related to your subject. And I'll do the search and try to get one publication that is kind of aligned with the subject I'm looking at. So this actually seems quite good. Took a look at it. Reduced order model of thermal viscoelastic filaments in a material extrusion process. This is the subject I'm actually interested in. So I'm gonna start with this. This is going to be my starting point. Ideally, at some point, I'll have to read this publication. But before taking too much time trying to understand all the general aspects related to this field, what type of techniques people are using, methods, what are the different ways to address this subject. We'll try to get an overview as quickly as possible about this field to understand where this work is actually situated within that field. So to do that, the way I do it today is that I'll first identify the DOI of this work and I'll copy it here. And I'll use a tool called Connected Papers. This tool has been around for quite some time, even before LLMs and ChatGPT. It's really convenient. You can paste your DOI here for the paper, click on the paper, and this is going to build a graph that shows you the connections between this paper and other publications. So it's mainly publications it cites or publication that cites it. So the paper we're looking at right now is kind of new, not cited by many people, but it's citing a lot of work. So once I do that, I'll also start downloading the PDFs of works related with the subject I'm looking at. So I'll, for example, download this one, download the PDF, and then through the Connected Papers graph, I'll go through the titles and try to identify additional publications that are close to the subject I'm looking at and download them. So for example, this one doesn't look too bad, so I'll start with that. We'll be able to refine later and identify specific publications we'll really read in details, but for now our goal is to get a quick overview about the subject. So before, this is part of the work that used to take me a lot of time, but today, thanks to the tools I'm be showing here, I'm able to do it much faster. So I'll just keep downloading a few papers. So at this point of the process, I have a bunch of publications I was able to download the PDFs of that are related to my subject. They're not directly about my subject, and I'm not trying to identify publications I need to read in details right now. That's the next step. That's what I'll do after that. So once I have these publications, I'll do one thing is that I'll use NotebookLM, which is a tool by Google here. I can just open it. It's free right now. Maybe it won't be forever, but for now it's free. I can click Try NotebookLM, create a new notebook, and here it's asking you for sources. So I'll take all the PDFs I chose that are related to the subject I'm interested in and upload them. Might have even one that I'm uploading twice, but that should be okay. And it's giving it a title and providing a kind of summary about the subject here, but this is not directly aligned with what I want. So what I'll do is that here in the chat area, I'm gonna provide some instructions to help me with the next step. So the instructions are going to be, actually, I can copy this here, paste it here and start from this. I am investigating reduced order models of melt extrusion additive manufacturing. Write a prompt for a deep research by Gemini about this subject. And now I have to be a bit more specific about what I specifically need. I am specifically interested in the methods, models, and strategies used to model the FDM, FFF, FGF additive manufacturing processes using reduced order models. Let's give it a second. So what NotebookLM does is that it'll only use and rely on the sources we provide here to actually answer your questions. So it's a kind of chat that's restricted to the documents you provide, and it'll avoid or it'll do its best to avoid providing information from the LLM itself. It'll also always provide sources. So here we have an answer. Please provide a comprehensive research answer on with a specific focus on the methods model, exactly what we want. So this would be the prompt, and it's actually giving us a very long prompt. So I'm gonna, we're gonna try this one out. I'm gonna copy the whole prompt. I never tried this one specifically. And then the next step is to go to Google Gemini, and we're gonna have to paste this. I might need to do some editing because it's actually copying the numbers. So the numbers in NotebookLM, if you click on one of the numbers, it'll actually show you the exact source and from the documents you provided that explains why it's saying this. It'll provide references for anything it answers, actually, to prove that what it's providing you with comes from the document. So this is in itself a great tool, and we'll be able to use it later to interact with the LLM, the chat here, about our documents. But right now, we're not sure yet. We have the most important publications and documents for the review we want to do. So we'll do that later, and we'll maybe create a new NotebookLM with the specific documents. And we're still trying to identify the most important documents and even keywords. I'm not sure yet I have the right keywords to study what I want to study. In research, it's usually hard because there's many words to say the same thing, and you have to identify the right one. So I'm going to do some editing, and I'll be right back. What I'll basically do is just copy the whole prompt proposed by NotebookLM, remove all the numbers and dots or buttons like the ones here, and then which will make it easier to paste in Gemini right here. All right, so I cleaned up the prompt a bit. So I have my prompt right here. I'm just gonna select the whole prompt, copy it, and then paste it here in Gemini, which is also free. Paste it right here, and I'm gonna click on the deep research button here, and then we're just gonna start this. And what should happen now is that Gemini is gonna process our prompt and then propose a plan to start a deep research about this subject. So deep research is basically when you're interacting with the LLM, but the LLM has tools that allow it to connect to the internet and perform Google searches and find references, documents about the type of prompt or query we're providing, and then it'll read those, analyze them, and try to keep evolving through its search until it really comes up with a report and sources that answer your question. So in this case, I won't spend too much time on this, but it kind of reformulates what it thinks you need it to do. And if you actually review this and realize that it's not exactly what you want, or there's some stuff you don't care about, you can always click edit plan and modify the plan before starting the research. This time, I'm just gonna start the search and let it do its work. So this is a process that's going to take some time. It's gonna take, sometimes it can take a minute or two, and other times it can take 15 minutes, 20 minutes, 30 minutes. So it's starting by going through 8 websites right now, and it's actually explaining what it's doing. It's going to read those, and based on these, it comes up with new questions, new search queries for Google, and it keeps searching, and it'll keep doing this. And you can actually leave this window. You don't have to stay here. It'll be available in your list of chats on the left, so you can come back to this whenever. So now we just let it do its search. While it's doing its search, we can go back to the NotebookLM here and start asking it more questions to try to clarify the sources we have. We can actually ask it for other things, like, for example, right here, a timeline. So it will build up a timeline that explains based on these documents, what happened in which order about this subject that we're investigating, the thermal analysis of fused filament fabrication. And I chose papers that, as much as possible, try to be aligned with reduced order models. So then we can open this note here, and in the note we have detailed events that explain, based on the publication, what happened and in which order. So you can go through this and try to grasp what's happening. It also gives you a cast of characters. You can see the basically researchers presented as characters from like a movie or some universe where people study this, but this is really convenient to understand the story of what happened. So this is the basic note. You can generate an FAQ, a study guide, briefing doc. You can ask it for questions, flashcards, if it helps. But one of the most interesting features is the studio here, where you can generate a podcast about the documents here, and it'll create a podcast with two characters who are actually discussing the content of these documents. So you can also customize this by clicking here and specifying that you'd like it to focus on some specific aspects, or to, I don't know, focus on the experimental parts only of the work. Be sure to mention all the methods, or go through each method mentioned in these works and detail them. Give me explanations in detail about what they're doing. You can ask for a shorter version, a longer version. And once we generate this, I'll just generate the default one based on the 9 sources. There's also an interactive mode where you can play it and you'll hear the two characters talking about the work, and then at any point you can click here on I think interactive mode, which allows you to ask them questions with your microphone and get answers about the documents here. So it's also a good convenient way to quickly explore the content of some PDF documents you have. So if we go back to Gemini, it is still investigating, so we're gonna let it do its work. So it's going through all these documents, and it's explaining what it learned in each case, and what is the next research step based on that. And in the end, we'll get a full report about this that we can export to Google Docs and analyze, but also that we can get as an audio file. And this is actually the next step usually for me, is that at this point I'm gonna export an audio file based on the deep research here by Gemini, which I'll show right after. And if I already have some good sources, and I'm confident that the sources encompass the subject I'm interested in and are not like too far away from it, I'll also download the audio file provided here and listen to it. So once I have the audio files, I'll listen to them while doing something else. It's a good first layer that allows me to quickly understand what the field is about. The next day, I'll probably, or after listening to the files, go for a walk, listen to them. I can come back here and in the audio overview interact with the, if I have questions, just interact in using my voice and the microphone with the characters here, and they'll provide me with answers by looking into the documents. But usually I won't do that yet. I'll first, based on the deep research result, the document I'll read, and the audio file I'll listen to that summarizes this deep research, it'll allow me to have better keywords and to better search and narrow down what I'm actually interested in. Some specific methodology, some specific type of works. And once I do that, I'll compose another NotebookLM project in which I'll have a better certainty that the PDFs and publications provided here are actually what I'm interested in. And that is the one I'll actually export as an audio file and maybe interact and ask questions about, because I know that those are the answers I'm looking for. Maybe once I get the right keywords and have a narrowed down version of what I'm looking for, I might also go back to connected papers and look for another paper, because that paper might be better connected with what I'm interested in. Usually while I'm doing all of this, there's another tool I use, which is Zotero. I create a folder in my Zotero bibliography manager, reference manager, and in that folder I'll save all the interesting publications that I found. So for example, maybe if this one, which seems like it's aligned with what I want for this topic, I might just save it in my Zotero folder, and I'll do that for any publication or source that I find is actually interesting and aligned with what I want. So I'll let Gemini finish here to show the next steps, but this is pretty much the first step of doing a literature review about a subject and learning about it as quickly as possible using these new tools that we have available, LLMs and generative AI. So these tools are good at analyzing natural language, I won't say understanding natural language, and then generating natural language. And in between, they can do things like synthesizing, summarizing natural language. So I won't rely on them to write a literature review for me, maybe to review it with auto peer review. That's actually convenient, autopeerreview.com, but I'll use them to quickly explore the field and better understand what I'm looking for, which is something that used to take me a much longer time before. And usually while all of this is going on, I'll actually be reading publications. It's like an assistant that you have in the background. So I might actually start reading this, which already helps me better understand what the field is about. And once this is done, I'll come back here and maybe download the audio file and listen to it while driving or something, so that I'm fully ready the next time I sit in front of the computer and better know what I should search for. So here we can also see all the files that the websites Gemini is currently browsing for us. We don't need to open them all because some of them are actually not relevant. So we better wait for it to finish and give us the final report with only the interesting references. Reading what's written here can also be interesting because it, for example, explains here the different methods used, the numerical techniques employed to balance resolution and efficiency, which is what I'm looking for in this case. And now it's actually concluding the research and future outlook, so we should get our result soon. So we got our report, it's now ready, and it's going to be a detailed report. It's going to take some time to read, but it's a good summary about the subject, which should make it faster for us. I actually might not read this right now because I'm not certain all of this is aligned with what I need. So I'll do two things. First thing I'll do is that I'll export it to Google Docs, like this. Might have misclicked. Anyways, everything is, a pop-up was blocked. Allow it. Done. Let's do it again. So while it's exporting it to Google Docs, the second thing I'll do is that I'll go to create here and I'll create an audio overview. I'll click on this button and it's gonna take some time again, but it'll generate a podcast with 2 characters that are actually going through this and discussing it. And this is what I'll usually start with. It's a way to get a quick overview about this subject. At the same time here in the report, what's interesting is that for any paragraph, there are references and sources that you can open here. So we can just take a look randomly, and we have here some references that explain why each part of the report was actually written and how, and we have different methods that are presented with tables, characteristics, advantages, disadvantages. So it's a good way to quickly explore this field. As you can see, my Google Doc export might be a bit slow, so we'll try it again. Export to Docs, but this time I'll just give it some time. You can export this to Google Docs, and I usually review it there. The references are provided at the end of the Google Doc, and so you can get back to it. But first thing I'll usually do is download the audio overview once it's ready, listen to it while driving, walking, or doing something, and then come back to the report. The audio overview is basically a way to quickly go through the report, and then you can explore the report in more details, look at the references and identify the keywords and references, publications. Sometimes it's not publications, other sources that are really aligned with what you need, and start again from there. So take one of those, put it in connected papers, identify papers aligned with that, Google the right keywords, maybe change them a bit, go through Scholar this time to really find publications aligned with the field you've identified, maybe the method you identified and are most interested in, and then try to get PDFs from those publications. If it's a website, you can download it as a PDF from Chrome. And once you have your PDFs, create a new NotebookLM project, upload them in there, and then you can download the file, download the audio overview of that subject, and start asking questions while going through the publications. So here what you can also see is that we finally got the audio overview. So I'll just ensure that my audio is actually recording. Yeah. And we can listen to the audio overview.
We've all seen a 3D printer working, right? It seems almost, well, magical, watching an object just appear layer by layer. But what if I told you that underneath that smooth process, there's this whole hidden world, like a microscopic battlefield of forces?
That's a good way to put it.
Hidden stresses building up, tiny cracks forming maybe, even the way the plastic melts inside the printer. Apparently that can decide if you get a perfect part or, you know, a useless mess.
Absolutely. It's all happening down at that level.
So today we're diving deep into how scientists are trying to see all that invisible stuff, using simulations to predict problems, maybe even prevent them before they even hit print.
Exactly. It's about getting ahead of the game.
We're looking specifically at simulating fused deposition modeling, FDM, which is probably the type of 3D printing most people know.
Right, the filament-based kind.
And we're drawing on some really cutting-edge research here from journals like the International Journal of Engineering Science, virtual and physical prototyping, polymers, stuff that really gets into the weeds of the engineering and the fluid dynamics.
Length of the stent.
Just from a tiny starting point.
Exactly. And similarly, a crack starting the second layer was very likely to spread outwards, radially.
Yeah.
That dramatically increases the risk of the layer itself failing, intralayer delamination while the stent is actually in use.
That's incredible. So it's seeing failures within a single.
So we can listen to this first file just to try to get some keywords, better understand what we're looking for. But at the same time, what's really cool is that we have this interactive mode, which I'll try to use right now, where if all the settings are correct, if we press play.
We've all seen a 3D printer work.
Hey there. Want to share your thoughts on this?
Hey, so I'm curious about different reduced order models. If you can give me a list that are being used today to model in a computationally efficient way the process of melt extrusion additive manufacturing.
That is such a great question, and we love that you're jumping in.
Absolutely. It's a critical area in this field.
So when we talk about reduced order models, we're really getting into how scientists make these complex simulations faster.
Because full-scale simulations are incredibly computationally intensive.
Exactly. One of the primary motivations for reduced order model is that older, fully detailed simulations, especially those trying to capture things like viscoelastic behavior or phase transitions, are just too slow.
They often require unreasonably large computational times.
For example, some fully resolved simulations could take up to 30 hours on a supercomputer with 36 parallel cores.
Which is just not practical for design iterations or real-time control.
So a key reduced order model that's been developed, and one our sources highlight, is a reduced order thermoviscoelastic model.
This specific model focuses on the thermoviscoelastic behaviors of filaments in the FDM process.
And it does so with really high efficiency. It's built on something called discrete differential geometry.
What's fascinating here is that it simplifies the kinematics of the filaments.
Instead of tracking every single detail, it uses a centerline and time parallel frame combined scheme.
This allows it to capture things like stretching, bending, and twisting.
But in a much more computationally efficient way.
And it still includes critical aspects like viscous effects.
I'm just going to interrupt them.
We've all seen a 3D printer work.
Thank you. So as you can see, we can interact with the speakers and ask them specific questions, and it affects what they're telling us, so they can answer our questions. Now, the cool thing is that there's an app for NotebookLM. So you can have it on your phone, open this notebook, and start talking with the two speakers at any time, at any point, even if you're not sitting in front of your computer, and explore the subject deeper. And see, they gave us the name of a method that's being used and why it's being used and what it actually models and doesn't model. So we can start again from there and investigate that method, and through connected papers get more papers that are more focused on that specific subject, which is what we're looking for, those models that don't require too much computations for the process of additive manufacturing. And again, compose a more focused NotebookLM, create our file, download it, listen to it at home, or maybe just, open the app and listen to the file from the app until we feel more confident about what it is we're doing. And then you can keep this NotebookLM. This is not a page or document you're going to destroy, because once you're writing something related to this subject, you can ask questions here. You can go back to the chat and ask specific questions about the documents, and it'll get you the answer and show you where in which document and where in the document the answer is specifically. So again, writing with this tool is not recommended, but using it as an assistant to help you write faster and help you understand faster what you're writing is really convenient and completely changes the game. And once you have everything in order, you can use a tool like autopeerreview.com to maybe review what you produced as a written content. And last thing I'd like to show is that for this report that we got, detailed report about this subject that basically expands outside of the documents we got here. So the one we're listening at here in NotebookLM focuses on the content mentioned in these documents. So this report that is actually not loading on Google Docs, the first time it happened, I'm going to try one extra time, because what you can do is download it as a PDF from Google Docs and add it to your next NotebookLM so that its content is considered with the new publications you add to your new NotebookLM. But at the same time, we have an audio generated that describes the report. So this version is a short version, 6 minutes, but we can also generate when we go to create an audio overview, we have the choice to choose a longer version or to give some specifications about what we want specifically from that audio. But again, we have an audio that summarizes the report.
Welcome to the deep dive. 3D printing is amazing, right? Creating these.
It's a massive boost for quality control. Fits right into this idea of a digital twin.
A digital twin. Tell me more about that. What does that actually mean here?
Sure. So think of it like having a live virtual copy of your.
The result we get with this report expands outwards from the subject we're looking we're studying. The result we get here is really focused toward the sources we provided, so you can really narrow it down to the field of expertise, really have something very narrow, very sharp about what it is you're looking at. If you're already an expert in the field, these tools are not going to help you much. Maybe they can help you better explore publications, but at the same time, if you're already very familiar with the subject, it's better for you to just read the publication. You learn more about that. But if you're getting started, especially if you're a student and want to quickly get into a subject, these are great tools to get started. And if you're writing something and need to have a good literature review that encompasses the whole subject, these tools can also help you a lot with that. So that's it about this subject. Hope that students, especially the ones that work with me, will be able to use these tools so that they can get started faster on their literature review and subjects, and we can spend less time finding sources and summarizing them and understanding them. So this can help boost and accelerate this part of your work.